Hi, good afternoon. My name is Louis Sormel, Senior DevOps Advisor. I'm going to show and demonstrate how and why we containerize application with Docker. So let's get started. What are containers? In fact, containers are an isolated, resource control, and portable operating environment. They provide a location where an application can run without affecting the rest of the system and without the system affecting the application. Internally, a container looks similar to a freshly installed physical computer or virtual machine, but it differs in its structure, which we're gonna see that later on in example. When you create a container, its external dependency are packed within the container images. Container have a layer of protection between host and container and between containerized processes. Container share the kernel of the host operating systems and rely on that host OS for virtualized access to CPU, memory, network, and registry. What are containers? Container versus virtual machine. The main difference is container are often compared to hardware virtualization technology such as virtual machine that use Hyper-V, VMware, or VirtualBox. However, containers are not the same as virtual machine. The main difference between the two is that all containers share the same operating system, so while virtual machine only share the hardware. Containers use the concept of operating system virtualization, while virtual machine use hardware virtualization. Immutability. Container provide the capability of immutability. When you start a container based on a container image, you make a change to the running environment. However, the moment you stop the container and start a new instance of the container, all change will not be available to the new instance. If you want to capture the state change, you save the state to a new container image after you stop the container. We're gonna also see that later on. Only after you create a new container instance based on the new image will you see the state change. Less resource intensive is also an advantage up from the immutability. Compared to running virtual machine, running container require relatively few resources. This is because the operating system is shared across the other containers. When you start virtual machine, you boot the whole new operating system on top of the running operating systems, and you only share the hardware. With containers, you share the memory, the disk, and the CPU. This means that overhead associated with starting a container is very low, and that containers also provide optimal isolation. Fast startup, because running a container requires only few extra resources of the operating system. Startup time is very fast, roughly equivalent to the time of requiring the start of a new process. The only additional things the OS needs to set up is the isolation of the process, which is done at the kernel level, and it's very fast. It's also improved the server density. When you own hardware, you want to utilize that hardware as efficiently and cost efficiently as possible. With the introduction of virtual machine, we made the step of direction by enabling share of hardware among multiple virtual machines. Container takes, at contrary, container takes this sharing concept to another step and enable us to utilize the memory, disk, and CPU of available hardware even more efficiently because we only consume the memory and CPU that we need. This results in few idle running servers and better utilization of the resource that we have. This is especially important consideration for cloud provider. The higher the server density, the more cost efficient the data center become. So it's not surprised that containers are receiving a lot of attention, that new tools for managing, maintaining container solution are emerging. As a great example, it's when we go in the cloud, we tend to not move out from from our on-premise data center all virtual machine into the cloud, because it's not really cost efficient. So it's why we tend to containerize the application before going in the cloud. How to containerize? In fact, we will go more in hands-on. So how we containerize? In fact, we need a container image runtime such as Docker for desktop. In that demo, we're gonna use Docker for desktop, but also Podman desktop is also another solution. But both container you create with Docker or Podman are compatible between the two, because it's just a container image runtime. So let's see what we have. Yeah, for today we're gonna we're gonna containerize with the Linux container. So we're gonna go there. Oops, little problem here. It's fun. Okay. So right here I have my .NET application. So my .NET application, I will go inside. I simply have .NET 6 application. We're gonna move it to .NET 7. Cool. Sorry for that mistake. I just forgot to move it to .NET 7. And I don't have the runtime installed on my machine. So let's start it. It's a stupid Hello World application which run on board. Hello's board 2237. So nothing fancy here. Really a simple application. In that ASP.NET Core, run on localhost 7237. So now what we want is to take that application, put it inside a container. We want to run it through a container, not through my operating system directly. So what we need when we need to create a container, it's simply we need to create a Docker file. And I need to say to that Docker file here that I want to use the .NET. I want to use the container image, the .NET-SDK version 7 of the for the runtime. So firstly, my application now, I need to build it, because yes, of course, I built it through my machine for sure, but we have different option here. We can build it on our machine and then push the binary file inside the container and so on. But the way to go normally is to build it inside the container with a multi-stage Docker file. So it's why I have that SDK defined as a build, and then I will build it. So my working directory will be app. I create it, and then I will copy all the stuff sfc dash. So I will copy everything I have under source folder, which contain my project file, and I will build it simply basically from the inside the container. One thing for sure I don't want inside my container, because I don't want to copy everything like binary file that has been generated from my local build. I don't want the object file, object folder, so I'm gonna have Docker in your file, and everything under binary and everything under OBJ. I don't want that inside my container images, because um, it can add more time to copy the content. It will take more time basically, simply to generate the container image for my application. It's more true with Angular project, because it tends to copy the whole node module folder, which sometimes takes um, around over the time around 10 gig of space. And with npm we tend to feel that we pull the entire internet when we do a build. So it's like that. So I will stick to that, and then I will simply do we'll start Docker. Let me start Docker. Okay, I will start Docker. Oops, I have 2 minutes here. So I'm starting. So Docker is starting. Docker is started. What I have, if I do a Docker image, I have a lot of image right now. So I'm gonna maybe clean my mess. Preferences. Sorry, I will clean my mess. I will simply do settings. Sorry, just a clean purge. And now it's restarting. It's still restarting. It's starting. Okay, it's started. So I'm gonna go back to my console, my terminal console. So Docker image, I have nothing right now. So that's cool. What I want to do is, okay, when I will do a Docker build, it will simply execute the command I put inside the Docker file itself. So it's gonna pull that image, and then I work like this for this demo. So I'm gonna tell inside the context of the container that my working directory, after that it will be /app. So then I will copy the command copy /source took it from my my location. So it's gonna take everything inside the source folder and put it at the root level where I am, which is -app. So I'm gonna do it, and then it pulls, because I don't have it on my machine right now, because I purge my container registry on my machine. It executes one step. The first step is the from, and then I'm 1 on 3. So my layer are done, but right now I did not do anything outside creating. tangling image. This is the image. So if I want to name it, I will name it like dash test demo 101. So, sorry, I'm just stupid. Marker build demo. So it been quicker because the layer has not been, my Docker file has not been changed. Any file inside the the source folder has not been changed. So because nothing has changed, the layer are already existed. So it simply tagged the image I previously created with the demo 101. So let's add more stuff here because we want to build the application, and when the application would be built, then we will create the runtime container images that we're gonna use to run the application containerized. So I'm doing a .NET restore. I'm doing a build. I'm doing a publish. Okay, maybe publish. I will deactivate it. So let's do the same things. The restore has been really quick. So my application is built. I have no issue here. Let's see what's going on if I decide to simply do a stupid thing in my code. And you see that the code is really simple. Breaking the run. So I'm gonna intentionally, I'm putting the invalid method, save it, and then I will build it. So that's clean. Of course, the application will not be built, because why? Because of the method breaking. I did the error typo, but anyway, breaking the runs doesn't exist. So my build failed. Building my container is just failing. So let's get back to the proper stuff. So now I will be able to build it. It will work. And then I will publish the output generated by the .NET publish command, because I want to use that publish output to then put it inside my official container images that I will deploy somewhere, like Kubernetes. It can be app services in Azure. And this will be used as an official image to run my application. So intentionally, I put the configuration, I publish it as a release one. I don't need to build it because the publish, the build has already been done before. But I can of course, if I want, I can decide to rebuild it when I execute the .NET publish, but it's not really how I can say efficient to rebuild it. But anyway, you do whatever you want at that stage. The idea here is simply to show how it ends up having a .NET container application containerized. So at that stage, this is my build layer, my build stuff. So then to get the images, official images, I will need to prepare the finite stage of my container image construct, which is because it's a multi-stage container, multi-stage Docker file. So I'm gonna pull the ASP.NET 7.0 images because it's the runtime for ASP.NET, and same things. It's just a personal approach for the working directory. And then here over here, I will not copy and rebuild it inside that one. I will simply copy from the build stages the content of the folder app/out at the root of the app folder. So even if I do my build, and then I need simply my build. And then I will define my entry point. My entry point is it's the hello world, my hello world.dll binary file. So I need to run .NET dash blah blah blah. Okay. I will not speak about configuration file for the moment. Maybe part of another demo, because that subject with the configuration across with containerization concept, it's different things. What I can say for in the moment is when we containerize application, we tend to, in fact, we need to avoid to persist environment configuration inside the container. You want your container image to be agnostic from your dev, your QA, your production configuration. You don't want specific configuration there. Why? Because anybody that can access to that container image can extract the content of the full of the configuration if you put it inside the container. So we'll see that in other demos that we inject environment variables so when we deploy it in dev, we inject environment variables value different than in prod, or we use the mechanism of config mapping Kubernetes, or even more, or you tend to have a stateful services that your application interact with to get this configuration. But there's a lot of different scenario where you can work with, but the idea I want to tell is to not persist production or any kind of environment configuration inside the container image. So right now we have everything we need to create our official Docker container image that could be pushed in any container registry in order to be pulled by a Kubernetes cluster or an app services to run it agnostically from the environment we need and we desired. So let's build it. So Docker run build tag test demo 101. So we have it. We didn't change much of things as we did before. Both run the ASP.NET 7, and what we have here is already demo 101 container image, which is our final container image. We see that the size is almost 200 megabytes instead of 800 megabytes. This one here was generated because it's another layer. It's the build layer. So we see that the SDK took more spaces, and also we know that that container images took small space because it contains all the source file, the binary, the object folder, and the final publish. So then after that, we create our official container image, which contain only the binary file generated by the publish. So we're gonna start running it. So simply to show you that I don't cheat, I'm gonna go on localhost 8080. I have nothing right now responding on port 8080. So we're gonna start that container with the command docker run port -p 8080 dot double dot 80. So what's it mean? It's a Docker engine will expose the port 8080 and redirect it to the port 80 on the container image. I will add rm, which is meaning when the container images instance will stop running, it will simply destroy the container on my machine. And then I will tell the Docker run to use demo 101 latest, the tag latest. So, and it start, and then what we see here, we saw that our application is starting because ASP.NET exposed some logs at the start time. So we know that our application is currently running and it's not crashing. And now here we see that we are interacting with our wonderful, simple website in ASP.NET Core that is running inside a container. Okay. So I will do a Control-C. I will look at Docker PSA. I don't have any running container. It might be made sometime. It might be. It's useful to know the command docker run, but personally, it's not my preferred way of working because when we have to deal with a lot of environment variables that we want to inject inside our container image at development time, it tends to be a little bit messy to remember that we need to put a -e, -e, my, and then dev -e user personnel -e pw my secret pw and so on. So it tends to be not useful. So what I normally do is I create a file I call a simple Docker compose YAML file where I simply put all that stuff here. So the image, so the Docker compose file, you can look over internet. There's a lot of documentation about the Docker compose format. I'm at the version 3.1 of the schema of the Docker compose. So it tells that, and with a Docker compose file, you can have not only one container image that you can start. You can start a multiple container instance from that file. Example, I can, okay, here, the images of my app, it's not my Hello World 101, it's demo 101, latest. In fact, yeah, in fact, it will create that one. Because you can start, with the Docker compose file, you can do a lot of things, quite sometimes you can have a complex workflow with that. You can simply run it through an image that you have already built, like this. I did this, or you can tell Docker Compose to build it before running it. So you will avoid the situation you have to type docker build my app, docker build that dot. So let's do it here. I will do a clear Docker images, Docker system pool. I will simply clean everything. And I will show you demo 101 this Docker Compose. Okay, we'll simply avoid the situation I'm leaving space and character. So I will tell that with the Docker Compose file, I will tell build my Docker file under that name. and run it through the Power 8080 with those environment variables. So here you see that I'm setting the log level as environment variable. So when I will start it, I shouldn't see the info logging stuff. So clear docker compose up build. I force the build. And then I start. So it will take a little bit longer because we clean the tangling images. And sorry for this, I don't have a really high-speed internet connection. It's the only 50 megabytes, it's not quick. So you see that my application now, I only see a warning. I didn't see the info stuff. So get back to the Power 8080. It's responding. Okay. What if I decide to do a Control C? I will decide to add another app, which is the same. Okay. Oops. Da, 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 da. I forgot to tell that app here dash app, but I could have. Okay, I will keep it app my first app. And instead of the second app here, instead of running it with that warning and the error, I will simply tell verbals. It is verbals or trace. I will know verbals. Okay, everything is really verbose. In fact, default will be warning, and the other one will be verbose. So both will run, but I need to change the port. So the first would be on port 8080, the second one 9090. So let's do another, whoops, build of that. So right now we'll run twice my application. So the first one, my second app crashed because verbose is not existing. So I guess it's trace. And the second one is running. Okay, we'll start it again. Mm. So we see that the second app is quite verbose. The first one is not. And port 8080 response and HTTP Zacatos 9090 is also responding. So that's pretty simple and pretty. It's pretty simple and quick to simply containerize an application. Then the whole debate and structure about the configuration ways of putting the and injecting configuration will come. I will probably give another demo simply on that subject because there's some scenario that we need to avoid. yeah, that's basically it. Let me go back to the news. So, um, yeah, that's basically it. Let's cover the subject. So, in order as a reference, for the content of this basic demo, most of the content I get it from the configuration management for Dockerized containerized delivery. It was a course given on edx.org. I don't think it's still available on adx.com.org, but the yeah. And also I will share here's the link of the code I made for that demo, so I will give it to you in the link video. So thank you for your time. If you have any question, don't hesitate to ask me a question. I'm always available to respond and help. So thank you. Bye bye.